Okay, my peeps, the second part of what we're doing for today is division properties of exponents. Notice we're not even on 6-2 yet because all of these properties are properties that should have been learned and mastered in middle school, but I'm just making sure we know what we're doing here, right? So first we looked at multiplication properties. Now we're looking at division properties. So a quotient is an answer to a division property, right? And the rule here is if it's the same base, you can subtract, which is magic, right? Because when you do the product, when you multiply, you add same bases, the exponents, and here you just subtract. So I have m minus n. What does this look like? Well, let's just talk about this. If I have 4 to the 5th divided by 4 to the 3rd, I can simply just subtract the exponents and get 4 to the 2nd and resolve it as 16. Why does this work? Why can we do this? Because let's just look at what 4 to the 5th is, right? 4 to the 5th is 4 times 4 times 4 times 4 times 4, right? And 4 to the 3rd is 4 times 4 times 4. Now, we know we can reduce fractions if they have the same thing. So this would reduce, and this would reduce, and this would reduce. So we know we get 4 times 4, which is 16, right? So we can see how it works. But then from there, we know we can just know the rule and apply the rule, just like when we play any sport or we play any game, board game or video game or whatever. There's just rules you have to follow. And these are the rules of this, the game of exponents, right? So again, everything works the same, right? I can do this as a subtraction problem. 2 minus a negative 3, right? Which means I'm going to add them and resolve it. But I could also have, instead, I could have just taken the ticket, right? I have this ticket right here. So that means I would have moved it upstairs. So I'd have 3 to the 2nd times 3 to the 3rd. At this point, it's a multiplication rule, which is adding, and I still get 3 to the 5th and resolve it, right? I just need to know my rules. And you guys know this. So many of you love to play video games or board games or sports. And it's always about knowing how to use your rules to your advantage. And that's just what we're doing here. We're just using the rules to our advantage. So on this one, we know that that x on the bottom is just a 1. So we're going to go 3 minus 1. And then that y is still just there. And we're done. That's it, right? On here, of course, with negative exponents, it always makes it a little exciting. I kind of suggest you take the tickets first, but it's up to you, right? You can do your negative exponents. I have a negative 3 minus a negative 4, which will leave me with just a positive a, right? Just positive 1. Or I could have taken my tickets. If I took the tickets, then I would have moved a to the 4th upstairs and b to the 3rd downstairs and kept that b to the 2nd's just like not part of the game. It's just sitting there. Leave him alone. Leave him on the bottom. And then here you would know that I'd have 4 a's on the top, right? And 3 a's on the bottom, and that b squared, of course. These would cancel out and end up with just 1 a on the top. So it's really easy to see how this all actually works. You try, give it a whirl. If you're doing this from home, please pause the video and then see how you did. Okay, 4 minus 2 is 2, and 6 to the 2nd is 36. Now we have x to the negative 4th power. So here's the deal. I could take the ticket on this, right, and get x 1 over x to the 6th, or I could just add. And I know negative 4 and negative 2 is negative 6. Then I have to take a ticket. No matter what, I'm going to have to take a ticket on this, right? Or I could have taken the ticket first and gone x, pardon me, over 1, x squared times x to the 4th. And at this point I add, get x to the 6th. But really, it's up to you. Power of a quotient. So there's two rules to this. There's the positive rule, which means if I'm adding, if I have a product of, if I have two different exponents that I'm dividing in parentheses and they are to the power of something, I have to distribute, right? And so when I distribute though, and it's negative, I know that also everybody inside the family gets the negative exponent, so they have to flip. Let's take a look at what this looks like. So these are two separate rules. There's the positive rule and the negative rule. Let's first look at the positive rule. So I know everybody gets the third power. 3 gets the third power and 5 gets the third power. And then I have to resolve it. I get 3 to the 3rd is 27 and 5 to the 5th is 125. And I'm done, right? Over here, everybody gets the second power. So x to the negative 4th gets the, multiplies by 2 and y to the 2nd multiplies by 2. And then I have to take the ticket. Not done yet. Not done yet. Take the ticket, right? And move it on downstairs. Now, in this scenario, everybody has a negative power. So I'm going to go ahead and distribute that. I see that everybody on the 4th power, the base is 4, they can be resolved within themselves, and the D's can be resolved within themselves. So I can first take care of this and then distribute, right? Lastly, I take the ticket on there and get here. Or I could have chosen to distribute first. It's really up to however I like to play the game, right? I could have distributed to all of these first. And if I did that, I would have 4 to the negative 12th and d to the negative 6th over 4 to the negative 8 and d to the negative 10th, right? And then I would resolve here. And I'd have 4 to the negative 12th minus 8th, right? And then I would have, minus a minus. So I would end up with 4 to the negative 4th. And then I have d negative 6 minus a negative 10, which gives me d to the 4th. From here, I would just make sure I take the ticket with d to the negative 4th, and then leave d to the 4th on top. And then finally solve this way. It really, again, it depends on how you like to see it and how you want to play the game. Okay, everybody in the family gets the ticket. And we see that 2 to the 0 power, that's just going to go to 1. So I don't actually think about it again. I do notice that negative 3 on top is to the negative 4th power. So I know I have to not forget that there is a negative 1 in front of there, and it also gets the 4th power. But that's okay, right? So that's going to go to 1, and then I have to take the ticket, and everybody goes downstairs. And my final answer is 1 over 81 v to the 8th. Go ahead and try these. See how you do. Again, just like any other sport, it takes a lot of practice to just get used to how all the rules play out in every scenario, right? So go ahead and pause your video here and then check your solutions. So it just depends on which way you went on that one. We have another assignment on this, and we're going to review part of the assignment is looking at negative and zero exponents again that we did as a warm-up in class if you're at home, but you'll see that on the other exponent rules papers. Okay, have a great day.